today we are going to be talking about the future value formula. All right. And let's just start off with some basics. So the first thing that I want to discuss with you is before we talk about the formula and what it calculates and what all these different things mean, how do you know when you're supposed to use the future value formula? What do we use it for? How will we know if we're supposed to be calculating something in financial maths using the future value formula? What are the clues? Anybody got any idea? No, exactly the opposite. Ochpeng, hope I said your name correctly. Yes, Mamelo, it has to be some kind of investment or savings. Good. It has to be savings. Or it has to be a retirement annuity. Or it has to be a pension. All of these are paying a lump sum, not necessarily, Bianca, not necessarily a lump sum. But what is important is what Lesego has put on here. Okay, and together with Mamelo, Lebogang, and Gugu's answers. Lesego, very, very important. There has to be a regular payment, a regular equal payment taking place, a regular equal payment occurs. Okay, so it's different to a question like the ones that we've done before, where somebody invests money and then maybe makes another payment 3 years later, and then the interest rate changes, and then money gets withdrawn 2 years later after that. That is compound interest. Future value means the same amount of money is being paid into some sort of savings, investment, pension, retirement annuity, and this regular payment is going to accrue interest or gain interest over time and result in a large sum of money that will be available to the person at some stage in the future. Okay, so that's what they mean by future value. Okay, the formula, you've got it on your formula sheets. The letter F represents our future value. The letter X, let's just change our colors here. The letter X over here is your regular equal payment. Okay, so your X is your equal payment. Okay, and it has to be made on a regular basis. Okay, so it can't be skip one, miss what I mean, where there can be situations where they get missed, but those are special situations. But it has to be on a monthly basis or a quarterly basis or a half yearly basis. There is a regular payment. It's usually monthly. All right, the letter I we know all too well. That is our interest rate. Remember, we have to write our interest rate as a decimal, so we have to divide it by 100. Okay, so it's our interest rate. And now for the letter N. The letter N, when we are talking about future value, represents the number of payments that are going to be made. Okay, so we can also relate it to time because, if one payment is made per month, let's say for 2 years, then, we know that it would be 24 months for a future value annuity to accrue or whatever the case might be. So there is a link to time there, but you will see that in some examples on Tuesday next week, not now. Okay, so N represents the number of payments that are going to be made. Okay, because sometimes a payment can be made immediately and then again at the end of every single month, or sometimes payments are made at the beginning of the month. It just depends. Okay, so N represents the number of payments that are going to be made. Okay, so hopefully now you're feeling a little bit more confident about when you're supposed to be using the future value formula. Okay, so you've got to read the question very carefully, especially once, oh, and then you've got your eye at the bottom as well. You've got to read your questions very carefully. Um, because often with financial maths, it's a long, big paragraph and there's quite a lot going on. So we've got to be very careful when we read everything. So let's do this one as our first example. Okay, so Peter is saving or saves for a deposit on a house. He opens a savings account and deposits 1,000 Rand at the end of every month. Calculate how much money Peter will have saved at the end of 4 years if the interest rate is 8% per annum compounded monthly. Okay. So a good way to understand these sorts of problems, like with all financial maths, is for us to draw a timeline. So we've got T0, T1, T2. These are the months. Okay. And we're not going to go all the way down to the end. In 4 years, how many months would there be? There would be 48, isn't it? So that we've got T46, T47, T48. Okay. And here, Peter wants his future value. Okay, so he wants to be able to have saved up a certain amount of money by the time T48 rolls around so that he can use it for a deposit on a house. Okay, it tells us that he deposits, and the time of the month that he deposits the money is also important. He deposits 1,000 Rand at the end of every month. So, what are they implying there? What does that mean? What is that 1,000 Rand at the end of every month? What are they trying to tell you by saying that in the question, do you think? What do you think, Matrix? Why are they telling you? There you go. Good, Caitlin. Okay, that is our regular payment. Yes, Lebogang, he's making regular payments. Excellent. Okay, so because he's making these regular payments, 1,000 Rand at the end of every single month, we know that we've got to use future value. Also, it's savings. So we see the word savings as well. Okay, so those two things together, it's definitely future value. All right. So, sorry, I beg your pardon. So 1,000 Rand is going to be deposited at the end of every month. So here at T0, this is when he opens the account. So at the end of every single month, so in the first month, he's going to deposit 1,000 Rand. 1,000 Rand. 1,000 Rand. At the end of every single month, he deposits 1,000 Rand. How much money does he have at the end of 4 years if the interest rate is 8% per annum compounded monthly? So that's another bit of important information. 8% per annum, and it's compounded on a monthly basis. So let's go and write down our formula. Okay, so our future value is equal to X, our regular payment, 1 plus I to the power of N, and all of that is over I. Lesego, you won't get a question like that. Okay, it's got to be, it will always be a regular, it'll always be a regular payment, okay, of the same amount of money. Okay, they won't do that to you. Okay. They can make it difficult in other ways, but they're not going to make it difficult like that. All right, so you don't have to worry about that. Okay, so they're implying by saying calculate how much money Peter will have saved at the end of 4 years. They're telling us to calculate the value of F, his future value. X is equal to 1,000. 1 plus our interest rate is 8% per annum compounded monthly, so 0,08. And then remember, we've got to divide that by 12. That's it, Nhlanhla. Well done. Now we need to work out the number of payments that Peter will have made in 4 years. Anyone got any idea what N would be equal to in this case? Absolutely. Okay, so he's paying at the end of every single month. for 4 years. So that is 48 payments. Okay, good job. -1 all over our interest rate of 0.08 over 12. And really all we need to be careful of now is that the way that we enter it into the calculator, that we've done it carefully. Okay, what answer are you guys getting? I can see there's quite a lot of answers going up in the chat. Gugu, you'd write it as 48. Just write it as 48. You can write it as 4 times 12, but write it as 48. There we go. Okay. Yamkela, remember, N represents the number of payments. He's making 1 payment a month at the end of the month for 4 years. So there are 12 months in a year. And if it's 4 years, then it would be 4 times 12. Okay. So our final answer is 56349,92. Okay, which a lot of you have sent to me in the chat. Okay, well done. Perfect. Good job, everybody. So this really is a very simple sort of question. Something like this wouldn't be worth a lot of marks. There would be a mark for substituting into the correct formula. There's often either a mark for getting the interest rate correct or getting incorrect. So if they were being kind or making this worth a lot of marks, they could give you a mark for the interest rate. There's often a mark for N getting incorrect, although it wasn't difficult to get incorrect in this situation. And then there would be a mark on our answer, like so. I think probably 4 marks for this would be too much, but we've got to start with things that are simple, and when we understand that, we can do the ones that are a little bit more difficult. Okay, is everybody all right with that? Can we move on? Are we all feeling all right? Good. Good stuff. Okay, so now let's look at something that is slightly different. Okay. So we have Thomas, and he starts saving money in a unit trust fund. He immediately deposits 800 Rand into the fund. So we've got to talk about what that means. There's an immediate deposit into the fund. Thereafter, at the end of each month, he deposits 800 Rand into the fund and continues to do this for 10 years. Interest is 8% per annum compounded monthly. So that's also important, 8% per annum compounded monthly. Calculate the future value of his investment at the end of the 10-year period. Okay. Aha, Ayanda. Good job. All right. So I don't know if the rest of you have seen what Ayanda's put into the chat, but Ayanda is saying +1. What are you plussing 1 to, Ayanda? Can you tell us? What are you plussing 1 to? Aha, you're plussing 1 onto N. Okay. So in this scenario, okay, Lesego, we're going to talk about it now. Okay. So in this scenario, we have T0, T1, T2. These are the months, because remember, it's a monthly payment that Thomas is making. Tick, 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 all the way down to the end. So 10 years, right? So 10 times 12 would be 120. So let's go 118, 119, 120. Okay. If Thomas deposits money immediately, and then again at the end of every single month, how many times has he deposited money in the first year? I'll say that again. If Thomas deposits money immediately, and then again at the end of every month in a year, how many times has he deposited money in the first year? Exactly 13 times. Good. Okay, so that is why there is this +1, because there is this immediate first payment of 800 Rand at T0. And then he does it again over here and again over here. So by the time we get to T12, he's made 13 deposits of 800 Rand. And then he does it again here and again here and again over here. And we want to calculate the future value of his investment. Okay, and then from start to end, his interest rate hasn't changed. It's 8%, 0.08 compounded monthly. It needs to be divided by 12. So that's why we've added 1. Who asked me that? Hang on, let's go back and have a look. So Lesejo, this is the reason why, because he is depositing money every month in a year. So that's 12 times in a year for 10 years. Okay. But remember, in the first year, there are 13 payments because there are 2 payments in the first month, one at the beginning of the month and one at the end of the month. So that's why we are plussing 1 onto N and getting 121. Okay, so now does that make sense? Okay, good. I'm glad. Okay, so there's just a little, so again, you just got to read it very carefully to understand what's going on here. Okay, so now he deposits 800 Rand. So there's 800 Rand. 1 plus 0.08 over 12 to the power of 121 minus 1. And then all of that is over 0.08 over 12. Okay, so again, just be careful. Some common mistakes of, or a situation like this where someone would write 0.8 instead of 0.08. So just be careful about how you put it into the calculator. What are you guys getting as an answer? Other thing that you must be careful of. Let's see. Good, Nhlanhla. Good, Ayanda. Well done. That's perfect. The other thing we need to be careful of, yes, Lebogang, Mamelo. Well done, Nondamiso, Gugu. Nice. There was something else I wanted to tell you to be careful of, and now it's completely slipped my mind. Yes, let's say good. What was it? I don't know. Hopefully it'll come back to me now. I think it was something about rounding. You've got to round to 2 decimal places. I don't know. Anyway, so again, correct formula. Okay, in financial maths, if you don't sub into the correct formula, you're not going to get any marks. Definitely a mark on getting 121 here. I think there would be a mark on the interest rate here and getting that correct, and then a mark on your answer. Okay. All right. Everybody okay with this? Can we move on? All good? Cool. All right. So this question is the same but different. Let's just have a look at this one, and then actually, you know what I'm going to do? I'm going to give you guys, I'm not going to say anything. Let me just write the future value formula here for you. I just want you to practice this by yourselves. Okay. So I'm going to give you this question to do and the one below it. And I want you to DM your answers to me just so that I can see that we are all okay. All right. So do this one first. and then DM me your answers, and then I can just make sure that we're all right. And then we're going to do another one like that, and then we're going to look at something that's just a little bit different, since you guys seem to be doing so well at this. Oh, I remembered what it was that I wanted to tell you. I'll say it again afterwards. Okay, and Tlantla, good. Orotile, good question. Yes, it is possible. It is possible. I mean, these formulae that we're working with now are not really used in real life, because it wouldn't actually it's more complicated than this. This is sort of like a gross oversimplification. But yes, theoretically, it is possible for the interest rate to change. But again, that's not something that you're going to have to deal with in these sorts of questions. The way they make it trickier is by making it more difficult to work out what the value of N is, or that there are payments that end up being missed, or money stays in the account and it accumulates interest. It's like that. It's not because the interest rate is actually changing. Okay. Tuli, we fine. Mamelo, fine. Lesejo, all good. Lezuko, good. Zonda, Leanne, Bianca, Gadi. On Waba, just check your answer again on Waba. Is there, maybe you just forgot to press something on Waba? Yeah, oh, Lisa, there we go. There we go. There we go. There we go. Okay, Lesejo, good. Good, 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 good. Yes. Okay, Tsiriso, something's gone wrong. Tamia, something's gone wrong. There we go, on Waba, you got that now. Okay, so Tamia and Tsiriso, I'm not trying to pick on you, but let's just see if we can help you understand where your mistake is. Everybody else, you were cool. That's great. So X was 500. 1 plus your interest rate, 0.07 over 12. Okay, then here this was to the power of 72, because it was for 6 years. It was at the end of each month for 6 years. Okay, so N would be equal to 12 times 6, which is 72. Okay, 0.07 over, let's just go down a little bit, and then the 12 over there. Yes, Tariro, good. Nondamiso, good. Ayanda, good. Tabang, that's fine. Not necessarily, Lesejo. It's not always compounded monthly. So the question that I was going to do with you up there, maybe we can go back and have a look at that one. That was actually sick every half year. We can go and have a look at that. Okay, Lesejo, let's go. In fact, let's go and do that as our next question. You've made me change my mind. I'm glad you asked that. All right, so our answer here should be 44580,47. Tamia, do you know where you went wrong? Have you found your mistake? Good. Okay. I'm so glad that we could help you like that. Okay. All right. So because of Lesejo's good question. Lesejo, this is going to be the next one you guys are going to try. Okay, so again, I'm just going to put the formula down for you. You guys start reading it. Okay, so Unati, you've got to press the fraction button on your calculator and then put the X in the square bracket into the numerator and then use that big blue button if you've got a Casio to go down into the denominator and then press the fraction button again to put an I at the bottom. I hope that makes sense, Unati. Sure, Unati, not a problem. Okay. So what you would do is you would press the fraction button on your calculator. And then when you're sitting up here, that's where you've got to put in whatever you think your X is. And then you're going to press bracket, bracket, 1 plus, and then you're going to put in your interest rate. So in this case, it's 14%. So that would be 0.14 over, if it's completely, then you've got to decide. So this is interesting. Lisa has sent me an answer. Unati, you're getting the wrong answers, Unati. I wonder if I can take a picture, really help you. This is where the emulator would be such a good idea. Yolanda, can you maybe just DM Unati and just speak to them and
Yes.
just see if you can help in getting correct answers, please, and just see if you can figure out
Okay.
what's going wrong there, please. Thank you so
Okay.
much. Cool. Thank you. Okay, so this is a bit of a nasty one, isn't it? Okay. So I can see everybody. So Nhlanhla's DM'd me, Tabang, Lisa Kanya, Tiriso, Zonda, Leanne, Lesejo. So all of us are getting different answers, and no one's got the answer that I've got. Okay, so let me try and help you with this one. Okay, so sorry, I was trying to be not clever. I wasn't trying to be clever, but I was just trying to give you Lesejo, because you asked the question, and it's a very good question. Is it always compounded monthly? No, it's not always compounded monthly. In this case, it is compounded half yearly. Okay, so let me give you some assistance with this question, guys. Sorry, this was maybe a little bit. Okay, Mamelo, fair enough. Okay. What they are implying here is that there is an immediate payment. Okay, like in, where was it? This question. Here they state it outright. They say he immediately deposits 800 Rand into the fund. Whereas this is unfortunately not quite as direct. They're saying Jesse deposits 400 Rand into a savings account. 6 months later, she deposits another 400 Rand into the account. 6 months after this, another deposit of 400 Rand. And then she continues to make half yearly deposits of 400 Rand into the account for a period of 9 years from her first deposit. Okay. Calculate the value of her savings at the end of the savings period. Okay. So now we need to think about, all right, how many deposits of 400 Rand has she made? Now, they are implying that from this point onwards over here, then she continues to make half-yearly deposits for a period of 9 years after her first deposit. Okay, so here is her first deposit of 400 Rand. After that point, she then continues to do this for 9 years. Okay, she's doing half yearly deposits. So that means every 6 months. Half yearly means every 6 months. Okay, so if you deposit money into an account twice a year for 9 years, how many times would you have deposited money into the account? There we go, Tuli. There we go, Tuli. Okay, Luzuko, yes. There we go. There we go. Good. Okay, so 400 and another 400. Okay, so if you deposit money, yes, exactly, Tuli. Okay, so N is going to be equal to, all right, she's depositing the money 2 times a year, half yearly. She does this for 9 years. But then we have got this additional payment at T0 that she made, all right, when she opened the account. So there has to be a +1 in this case. So N is equal to 19. Okay. Google, let's see your answer. Just send me, yes, Gugu. Perfect. Perfect, perfect, perfect. Okay, well done, 100%. Yes, Lusejo, 19. Okay, so this is a difficult one. All right, it's unfortunately not as direct. The information is not as obvious as the first example that we did. Okay, but hopefully now we understand it a little bit better. Okay, so 400, and then we're all going 1 plus our interest rate is 14%, compounded half yearly, so we have to divide it by 2 to the power of 19 minus 1 over. Okay, so in Nhlanhla, if there was no immediate payment, it would be something like this. So John opens a savings account. At the end of each month, he deposits 500 Rand into the account and continues to do so for 6 years. Then there's no immediate payment. Let's see if I've got another one. The first one that I did with you. Okay, so Peter opens a savings account. He deposits 1,000 Rand at the end of every single month. Tariro, good. Well done, Tariro. Well done, Tariro. Okay, Nhlanhla. So you're going to see Nhlanhla next week on Tuesday. I'm going to do more difficult questions with you. Yes, of course, Lorraine. There's going to be a question I'm going to do with you where they tell us that there is an immediate payment, but in this case, we do not +1. Okay, so That's why I always say, oh, sorry, Lorraine, let me just go back and find my question. There it is. There it is. So that's why you've got to be so careful. I always say to every class I teach every year, and maybe I shouldn't say this, but in my opinion, it's just true. I think financial maths is the most difficult thing out of everything. Fortunately, it doesn't count for that much. But sometimes trying to understand these questions can be pretty difficult. Okay, Tsediso, I'm going to explain that again. Onwaba, yes. Leanne, yes. Lezejo, yes. Yes, correct, Lebogang. Half yearly and biannually is the same thing. Correct. Every 6 months. Good. Okay, so Tsediso, where did the 2 times 9 come from? Okay, so remember, Jessie was depositing the money 2 times a year for 9 years. Okay, she's depositing the money every 6 months. Okay, half yearly. So 2 times a year for 9 years. Does that make sense? Hope so. Okay. Cool. All right. How are we feeling so far, guys? Are we okay? Everybody all right? It is non-demiso. Good. Okay. Well done, everybody. Okay, we've got this. Nice. Well done, Matrix. Okay. Let's go and have a look. Mbalenhle, it will become easier with you the more you do these questions. All right, let's go and have a look at yet another one and decide whether or not there is an immediate payment or not. Okay, let's have a look at this one, and then we can go and have a look at. I want to do something that's a little bit different with you. Oh yeah, it's this one over here. Let's have a look at this one. Okay. Again, it's not very different from anything that we've already done before. We just consolidating the basics. Okay. Nandile deposits 1,800 Rand into a savings account. At the end of each month thereafter, she deposits 1,800 Rand into the account and continues to do this for 10 years. Okay. So in this situation here, just reading that so far, Mbalenhle, try and draw yourself based on the information. Yes, Teddy, so you're quite right. Try and draw yourself a timeline. Okay, timelines are really useful. We get no marks for them, but they're really useful. Okay, so when you read Nandile deposits 1,800 Rand into a savings account, at the end of each month thereafter, she deposits 1,800 into the account, even though they haven't used the word that she has deposited immediately. They're implying that. Okay, they're implying that in the first month, there are 2 deposits, one at the beginning of the first month and one at the end of the first month and at the end of every month after that. Okay, does that make sense to you? So in this case, we can see that at T0, when she opens the account, and then at the end of that month, she does it again, and then at the end of every single month thereafter, she is depositing this money. Okay, and she does this for 10 years. Okay, so that means if there are 12 months in a year, 12 times 10, we would get to T 120 if she's doing this on a monthly basis. Okay, so can you see here why there would be this +1? Okay, because we're starting to count at 0, we're not starting to count at 1. So yes, N would be equal to 121 in this case. Okay, so Tuli says that's the answer. Okay, Tuli, well, let's just check. Are the rest of you getting the same answer as Tulisiwe. Okay, I'm just checking Tuli. I'm also going to do it. Uh, you Speedy Gonzalez there, Tuli. Okay, so a whole bunch of you are putting answers in. That's really awesome to see. Let's see what you guys are getting. Nice. Yes, 100%. Good. Leanne, Nhlanhla, Mamelo, Onwaba, Tabang. Perfect. Okay, so just very quickly, let's just put this down for you. So you'd say future value is 1800, 1 plus 0.08 compounded monthly. Ooh, oopsie. 121 minus 1 over 0.08 over 12. Okay, and then just the other thing to be careful of, guys, is if you open brackets, make sure you close them. Yes, Nondamiso, Luzuko, Lebogang, Tuelo. Good, 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 good. Okay, if you open brackets, make sure you close them. So if you open 2 brackets and you only close 1 on the calculator, it'll give you math error. Okay, and then you'll think you've done something crazy wrong, but meanwhile, it's just because you didn't close a bracket. Okay, so just be careful of that as well. Yes, Mbalenhle, you've got it. Okay, good job. Yeah. So, yeah, again, just be careful at the end there, Mbalenhle. We've got 2157. So that 5 on your calculator is pushing that 1 into a 2. Okay, but remember, they're not going to penalize us for rounding errors like that. There's only going to be 1 penalty, and this is now trials and finals. There's only going to be 1 penalty on rounding in paper 1 on our question where we do in question 1 on the quadratic formula. Okay, but best for us just to get it right. We don't know, maybe we write a test this term or something, and our teacher penalizes us once for rounding or something like that to teach us a lesson. Okay, so again, correct formula, getting this correct, and there's our answer. Okay, let's just do something else before we run out of time. Not that. Yes, this is it. Okay. So again, there's so much for us to read here. It's a little bit different to everything else that we've done. Dana's just turned 20. And has a dream of saving 8 million rand by the time she gets to 50. So she's just turned 20. By the time she's 50, she wants to save 8 million. She starts to pay equal monthly amounts into a retirement annuity, which pays 18% per annum compounded monthly. She's lucky to get such a good interest rate. But anyway, never mind. Her first payment starts on her 20th birthday, and her last payment is made on her 50th birthday. How much will she pay each month? Okay, so what do we think they're asking us? Yes, Mamelo. Yes, both Ayanda and Mamelo, you're both correct. Okay, but you're talking about 2 different things here. Okay. Yes, so the question is implying we need to calculate the value of X. We're looking for X. Yes, Mikhail. All right. So subbing into our future value formula, let's just get it on the page. And then we can see what goes where. So this 8 million, I hope. Leanne, yes, we're going to talk about that now, whether how many payments they're going to be. Okay, so hopefully all of us are realizing that the 8 million has to be her future value, right? Or the future value of her savings is a better way to put it. Okay, so the 8 million is going to go over here. When we want to calculate how much she pays each month, that means we need to calculate X. The interest rate is not the hard part. That's 1 plus 0.18 over 12. And now again, we need to be careful about the number of payments. So if we're ever in doubt, we can do a timeline. So we've got T0, T1, T2. Let's just go down here and just go over a little bit. And and she does this for 30 years, isn't it? Because her first payment starts on her 20th birthday. So this must be her 20th birthday. Okay. And then we get down here to T358, T359, T360, and this is where her 50th birthday takes place. Okay, so there we go. We're starting to see answers now. Nice. So X goes in and X goes in and X goes in and X goes in and X goes in, and she makes her last payment on her 50th birthday, and she has decided she wants 8 million at the end of all of this. Okay, so what is n equal to? Leanne, what do you think? Is it 358 or is it 361? What do you think? How many payments now do you reckon? Yeah, Bianca. Yeah, quite right, Leanne. Okay, good job. Okay, so can you see how drawing the timeline really helps? Okay, so I encourage you to use that as a tool to assist you. Okay, not as I've said before, you're not going to get any marks for it. Doesn't matter. Okay, if it helps us to understand the problem, if it gives us a place to start, a way to understand things, etc., then it's well worth it. Okay, so now I can see there's a couple of different answers here. Lebogang and Leanne got the same. PC, you got a slightly different answer. Let's go and sub in and see where we may have gone wrong. We've all decided this has to be 361, right? Minus 1 all over 0.18 over 12. So now we have to rearrange. Okay, we are going to solve for x by cross multiplying the 8 million with our denominator, the 0.18 over 12. And then to isolate the x, we have to divide by our square brackets. Okay, so that's to get our x on its own. Okay, so this is quite a thing to put into our calculators, isn't it? Minus 1, and then we've got to close our brackets again. That's what we're doing. Okay, yes, Leanne, I see you've got a hand in the air.
Hi, ma'am.
Hi, Leanne.
I wanted to ask about the 361 payments. It says
Sure.
that she will pay, like she will also make a payment on her 50th birthday. I feel
Yebo.
like that payment that she makes doesn't have an interest. Therefore, I feel like it should be 360 instead of 361.
You're quite right. There won't be any interest on that payment. You're quite right. But that doesn't matter. That doesn't mean that there's only 360 payments. All right. So even though there's no interest on it, the payment has still taken place. What's important to note here is that she does this when she turns 20. All right. So on her 20th birthday, she's paying this amount of money. All right. So that is at T0 when she turns 20. Because she makes her last payment when she turns 50, all right, there is going to be that additional payment. So in other words, if you because essentially what's happens, you can either look at it as though it happens in the first year or as though it happens in the last year. It's actually probably better to look at it that it happens in the last year. In the last year, there would be 13 payments because the last payment takes place on the anniversary of her birthday. All right. So yeah, N is definitely 361 in this case. I hope that makes sense to you. Okay. And after calculating this, yes, we should be getting 558,41. Okay, sorry, that's supposed to be an R sign, not written very nicely by me. Okay, so in that last year, Leanne, there are going to be 13 payments, because the 13th payment of the year takes place on her birthday again. I don't know. I hope that makes sense. So if she stopped paying 1 month before she turns 50, then there would be 360 payments. Does that make sense? So if you think about this, think about, okay, Leanne, when is your birthday in a month? In which month is your birthday? June. Cool. Okay. So now let's pretend, okay, so this is now the last year of her life, but let's use you as an example. So let's say you do it in June 2023. Then you do it again in July, August. Let's just September, October, November, December. Then you go again, January, February, March, April, May, and then again in June. Can you see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so in that last year, okay, in her 50th year, or in her 49th going into her 50th year, this is exactly what happens. Okay, Leanne? Right, because she makes another payment in the month of her birthday. Does that explain it a little bit better for you? Okay, so if you were saving money, Leanne, and you started in June, okay, and then so you start, let's say you're 18 now, maybe you're 17, but let's say you're 18 now. So in June you paid money, and then you paid money again July, August, September, and then again next year when you turn 19, or what, if that is how old you're going to be, you pay again. You're going to have made 13 payments. Okay, because essentially because from June through to May is 12, plus another one would be 13. Okay. All right, everybody. What we will talk about next week is how we would calculate N using our future value formula. And then, as I said, some sort of slightly more difficult questions where they use the word immediate, but you don't actually +1, and you'll see why, etc., etc.